Okay, if you look in the lecture, I believe it is on page 12 where I say example 2. Okay, so what I do is I show if you have an extreme value that the mean gets bigger and the standard deviation ends up being larger. Okay, so an extreme value will throw off the standard deviation. Okay, I also show you in the if you add those all up, it's 120. 120 divided by 4 is 24. I want to show you what happens when they don't deviate from the mean at all. Okay, 24 minus 24 is 0, 0, 0, 0. Okay, you add that all up, it equals 0. Okay, that's why we square it. But if you square 0, 0, 0, 0, 0. So if you were to say the sum of x minus the mean squared, that equals 0. Okay, divide that by 4, it's still 0. Take the square root of 0, the standard deviation is also 0. So on average, these data points don't differ from the mean of 24 by 0. Okay, let's say this is age. Okay, and that should make sense. Okay, so that's an extremely small number, right? They don't differ at all. Okay, so if we made, the more these group of numbers differ from the mean, the bigger the number will be. Okay, and you can look in the lecture and see those examples. Okay. Lastly, don't get freaked out by the formulas. This is the population formula, okay, because it's got the population mean. Remember, in a population, big N stands for the number, and that funny Greek thing is the mean. And in a sample, that's the mean, and the number is small n. Okay? So for a sample, it's a slightly different formula, but it's the same thing. X minus x bar squared over n minus 1. I'm sorry, that's s squared. This is just the square root of that. Okay, the only difference really in these formulas is it's this n minus 1 thing, okay, for the sample stuff. Don't get freaked out by that. I'm not going to get into it on this short video. It's already too long. It's just to account for small sample sizes. As the sample size grows, that has less and less of an effect on the fraction. Okay, it's an error thing. Because remember, whenever you sample from a population, there's always some error. That accounts for some error. Okay. But you should see an n there, you see an n there, right? It's no big deal. It's the same thing. Okay, that mean, that's a mean. So on average, how much do all these data points differ from the mean? Okay. And lastly, just so you know, if you did have extremes in your data set and the mean was a bad score, there is something else you can do that I'm not going to teach you, sort of like the interquartile deviation or something like that. But in general, if you were going to use this in the real world, I would say you could still use it, but I'd give them also the range and say, look, and show them how the mean is a little bit extreme, maybe not a good average. Okay. And then if you really want to do it, I think it's called the interquartile deviation, where it's sort of like between the 25th and 75th percentile. Okay, so that's that. Remember, if you're going to take the standard deviation, you need to have an interval or ratio level variable. Okay, because it's all based upon the mean. Okay, if the mean doesn't make sense, like a gender, don't take it. Okay. I mean, you can compute it, but it doesn't mean anything.